Hello everyone, and welcome to the Introduction to Modularization. Okay, you have reached a milestone in this course, and that's one that sits back and says you can now program. You should have a decent understanding of variables and how to declare variables, the scope of variables, and also now incorporating the sequential structure and the conditional structure into your programs. We got a lot of practice. This shouldn't be a time that you're frustrated or anything to still work on it. There's a lot of time to keep learning, and there's still a lot of learning to do, not only in this course, but in subsequent courses and really the rest of your career. Becoming better at programming is not something you just do overnight. You just got to work at it, and every experience is something else you can build on. Okay. However, with that said, once again, I want you to pat yourself on the back. You come a long way with this course. And if you kind of think about where you started with one line of code to where you are now, good for you, okay? And if you understand it, good for you. You're doing very well. And hopefully you're ready to take on the next subject here. The next subject, and really what we're going to talk about for the remainder of this course, is going to be what's called modularization, okay? And what this video is going to do is kind of walk through what the heck do I mean by that. You're going to discover we're kind of going to switch things up a little bit on you. And what we're going to focus on is not so much, building on everything we've done so far, is more reorganizing everything we've done so far into things that are called modules, in our case, procedures. And so we're going to spend a lot of time over the course of the rest of the semester learning how to do this, learning how to do it well, and practicing it, okay? It'll be assumed you know how to do this walking out of this course. So it's very important that you focus on this. I know it's getting late in the course and some people start getting tired. And the fact that we're changing things up kind of makes everybody sigh a little bit like, oh, God, why are we doing something new? Well, unfortunately, what we're going to be teaching now is truly how you program. And we want to make sure you understand it and start getting a good beginning on this. And again, you'll practice this not only in the rest of this course, but in subsequent courses throughout the curriculum. So what is this? So what we're going to talk about is what modularization is, why we're even talking about it, and how we're going to do it. There are several videos this week, so I want you to make sure you listen to them all and understand them all, and then follow all the instructions on practicing and so on as we keep moving forward. Okay, first, what is modularization? Well, up to this point, we have written all of our code in one procedure. You have seen from your code that our code has increased based upon not so much the complexity, but pretty much what's required of the program. Programs are not one line of code, okay? And as you discovered, you went from one line of code in about 8 weeks to about 100 lines of code. So it gets bigger pretty fast, okay? We've done this and we stayed organized in doing it. I actually begged you to stay organized in your programs. And if you follow what I actually asked you to do, you have done so that on your button click, you basically have 4 main sections: declare variables, get and validate your input, do calculations, and display results. I pushed you to do this pretty much because of what we're going to be doing now in the future, is organizing your code in a very readable format. That's been good, especially when our code has not been many lines, okay? So again, what's many lines? That's all relative, correct? But one thing you're going to discover when you hit the real world is that our projects that you're doing right now, where it's 100 lines of code, and you're going to get into projects that will go a little bit more than that, is not really what real world is. Real world gets into 1,000, 2,000, 3,000 lines of code. And when you have one procedure that does it all, things get a little bit more complicated to read and to follow. So far, not so much, I would agree, but it will. I'm not going to ask you to write a 1,000-line piece of code right now, but what I ask you to do is to sit back and just pretend that we can get to that point. And you will get to that point. So what we want to do is teach this methodology, if you will, how to program now effectively when things aren't so big, so you can actually do it well. Okay? So as a professional developer, we're not writing the code for yourself. One of the things, what is we're trying to do here is that when we write our programs in the real world, very rarely will we write the program, maintain the program, and enhance the program. At some point in time, it needs to be handed off. Maybe you'll do it for a little bit. Maybe you'll not do it at all. Maybe it actually goes to a whole nother group within your company. It all depends on where you work and how it's all set up. But eventually, you may leave that company or move on and do different things or get promoted, and somebody needs to pick up and take care of your code. So you're writing this code not just for yourself, you're writing your code for somebody else to be able to maintain and enhance. Therefore, it's important to write the code in a way to ensure easy understanding as soon as someone picks it up. And easy understanding is not picking up a piece of code that's 3,000 lines long and it just all kind of comes together. That's really hard to follow. I think you would probably agree with that. With that, software developers do not write long procedures. We don't write these 1,000-line long procedures. What we do is we split the programs up into multiple procedures. And so in this process was what's called modularization. So what you have seen before and what you have done before all in one procedure, what we want to start looking at is how to split this up into logical procedures, not really changing how the logic works at all, but into procedures that are separated. And what we can do is then call these procedures. And that's what we're going to learn about this week. So we mentioned one reason why, up to this point, easy to maintain and understand. There's really a lot of reasons why we're going to embark on this. Once again, easy to read, maintain, and understand. You want to be able to pick up a program. You want to be able to pick up a program that somebody else has written and be able to understand it as quickly as possible. Excuse me. You want to easier to initially write. I contend that how we're going to teach you to design this and do this should actually assist in your writing of the program. It's really going to force you to deal with one thing at a time. And if you've been having a hard time dealing with one thing at a time and really you can't get past looking at the whole and getting a little bit overwhelmed with the whole, this will push you a little bit harder to go back to dealing with one thing at a time. It's easier to potentially reuse parts of your program. What you're going to discover as a software developer is we spend a lot of time making sure that we don't do the same thing over and over and over again, especially in the same company you're working for. We want to do things right and right. We want to do it one time and potentially reuse that over and over again. So we just don't write the same thing in different programs. So this lends itself toward that. It also lends itself toward a methodology of object-oriented. We don't dive into object-oriented in this course, but you will in the some next courses you may be taking, okay? And object-oriented is a methodology that kind of builds on what we're going to be talking about now, but it's actually a little bit more powerful than what we're going to be talking about now. But again, its whole purpose is, once again, reuse and ease of understanding and so on. All right? The big obvious reason why you need to learn this is pretty much, like I said before, this is pretty much how professional programmers actually do it. And it's what's expected of you when you hit the industry. So it's something you want to learn and you must learn. So don't avoid this. Don't block it. Don't sit back and say, oh, God, I don't want to learn this and I'm just going to struggle through this as best I can. You really need to stay focused and learn how to do this. It's not very hard. At first, it'll be a little bit different, like everything, but once you grasp it, it's actually fairly easy, and you'll become part of programming for you very, very quickly, okay? How do we do this? The how of doing this is very subjective per programmer. What I mean by that, there's no exact one way on how we break up our programs. It's really up to you as a programmer, and maybe your peers that could help you with this in regards to how you split up your program. We'll talk about this. But the goal is to split your program up into different procedures based on what is called separation of concerns. That's the fancy word in industry, separation of concerns. It's almost the same thing. It deals with object-oriented also, but the whole idea is each procedure should only deal with one concern. In other words, one purpose per procedure. If you're calculating two things in one procedure, it should be broken up into multiples. Does that make sense? A great analogy of how to do this is basically outlining your paper. So if you have a paper or a textbook, so as a college student, I'm sure you've written many papers. Usually when you do this, you outline your papers. You put some headings in there. From a textbook point of view, there's chapters. So there is sub-chapters, sections within the chapters and so on. And why do we do this? Well, we do this to, ensure our audience understands. And that's exactly what we're doing now as we're writing our programs. If we're going to have to write 2,000 to 3,000 line programs, we should break this thing up so the next person can easily understand what is being done. And so you write it as such, like you were writing a paper or, like I said, a textbook, okay? In the next several videos, we will take you step to step to designing it and then also programming a modularized program. It will take practice. You must practice it. I'll give you different opportunities to practice it. We'll start simple, get a little bit more complex as we go. But however, modularize your program will now be expected starting now and really the rest of your career. You're going to have to learn how to do this because every course after this will require you to modularize your programs. Some languages are already based on it. How you've written it so far is not how many languages do it. Everything is usually split up. All right, so let's get started with that. Before we leave here, I just want to sit back and say, once again, you might be going, why? Oh, God. Once again, don't make this hard. It's actually pretty simple to do. You're going to find that your first few programs, you may look at this and say, I don't see the benefit. And you're not. Literally, when you get done with your first program and doing this, because the first program I'll have that you may do was probably only modularizing a program that was probably 20 or 30 lines. Next thing you know, you might have 50 lines because of what we're going to be doing. Don't base anything on that. Very few times you'll be writing a program that's 50 lines. We're going to utilize some of the simplistic programs you've already started, and we're going to build upon that, but to help you understand the process of doing this and understand getting it to work accordingly. And then as you keep going in the rest of this course and the curriculum, you'll start writing in larger and larger programs, and you'll start seeing the benefits very, very quickly as you go. Okay? So that's the process here. Hang in there, enjoy the ride, and let's see where we go. Like I said, let's get started.